What I have inside of that command file, I've recorded my previous work with this data set that essentially captures things like what is the list of variables that I'm about to use, what are the other settings, like what is the node sizes that are allowed, what is my target variable, like in this case I'm modeling retention, it's obviously categorical, the current priors settings, and so on. So I'm a kind of replicating run that I've done before on my own as part of our work with Dave. So I'm submitting this window. It has two data sets, train and test, that 50-50 split. And what you're witnessing right now is essentially the CART model building process. Again, 50,000 observations for learn, 50,000 for test. I get my relative cost performance curve here. Very quickly it reaches the point of learning, even though the suggested optimal tree has 56 nodes, which is somewhat an overkill for our purposes. So I will backtrack in the tree sequence to the point where I have only 12 nodes to kind of illustrate the nature of the solution that we get here. Now, notice the following. In the root node, my primary split happens to be market intensity at 21.5, whatever that number stands for. And initially I have a almost 50% response rate and about 50,000 observations. Based on that split point, my entire universe is now partitioned, if I go ahead and say compare children, is now partitioned into two sub-universes of roughly equal size. Well, there's a little bit of disbalance there. On the left-hand side, when I have low market intensity, my renewal rate goes up. On the right side, when I have high market intensity or high level of competitiveness, it goes down. And from that point on, these two parts of the tree will evolve independently of each other, each time producing higher and higher degree of fragmentation in my data set. Now, if you skip all that particulars of the story, I have terminal nodes color-coded according to the percentage of ones. Now, one stands for renewal. And what you will notice is that on one side, I have terminal node number 11 that has essentially a 77% renewal rate. And that's compared to the original 50%. So if I click on that node, I can confirm that finding by looking at the differences between learn and test partitions. So it's an example of a more or less stable node. And when I switch to rules, the joint presence of these three conditions, which is high market intensity. So in other words, I do have a lot of competitiveness. But at the same time, if there has not been policy change and a substantial premium increase, and I have a kind of a loyal customer, so it's like 10 periods already, and the car in the insurance, it's probably more like 5 years. So if those conditions are met, even under high market intensity, I'm actually getting good renewal rate. In fact, I'm getting one of the best renewal rates in this data set. In a similar way, on the left-hand side of the tree, when I click on this node, I can again confirm a very high stability of the renewal rate, but this time it works under the conditions when you have low competitiveness and, again, a pretty loyal customer. And that sort of highlights the nature of the segmentation. CART solution identifies segments with different response rates, and each segment kind of independent of everyone else. This is how interactions will ultimately sneak in, because I could feed a large number of different variables as long as the data set allows it and I have reasonable number of records to begin with. And those variables will identify that specific segment, and in some general sense, they'll interact. On the other side, I also have an example of a node here that has a very low response rate, renewal rate. It's about 25%. And there, the rules somewhat change, and it kind of shows, again, high competitiveness and a relatively high recent increase in premium, which basically drives those customers away from your company. They're looking for someone else, assuming, of course, that that someone else is easily available. Now, see, I've gotten this model within a minute or two. And it's a pretty large data set, but in that short period of time, I'm actually gaining a much better understanding of what's involved in my data set. I'm just looking at these different parts, the different segments, and trying to see whether it all makes sense in my head. Oftentimes, you'll discover the things that you see don't really make sense, and I will show some examples of that. Now, when that happens, almost always the explanation is that you've gotten corrupt data set, or the initial understanding of the variables that you had differs from the real meaning of those variables. And those are the kinds of issues that would have been difficult to identify without having something as powerful and flexible as CART. But let me move on and illustrate what happens if I now, you see, when people see a tree structure like that, and especially if you need to present it to someone else, you'll either get into someone who already comfortable with that, and you'll have no problems, or you will not be able to communicate the message because they will keep asking you for an equation or for some kind of main effect or something that would say, okay, you have that market competitiveness, show me how it enters into the picture. Now, what you could do with GLM, of course, you're just looking at that tree structure. I've started with about 12 variables, but if you look at the actual splitters or variable importance list deeper in the interface, you can actually see that those are the variables identified as important. So you can take these variables, go to GLM, or go to conventional tools, and you will be able to get to the solution at a much faster rate. Because I could have come up with this starting with a data set that had 200 or 300 variables. And CART would have picked the ones that are most important, most influential. And that alone could dramatically cut on the time, the running time, and so on. But in my case, I also want to see what you might do to bring it one next step forward into the modern days, when in addition to CART, we have more powerful data mining tools, in particular TreeNet, that has been winning all these major international and domestic competitions pretty much every year. And now let's see whether we can use TreeNet to go back to the GLM and maybe incorporate things in an even better way. So what I will do here, I'll keep, and that's where I'm using experimental version that hopefully will become available at some point. I simply switch to TreeNet process. I'm going to build a logistic binary model here. And the TreeNet has a number of simple parameters like testing, test sample. Let's highlight that same test file that I used before. And just for the illustration purposes, I'll build 200 trees with the learn rate of 10%.